Without wasting our time, let's quickly look at this mathematics question. What is the point of intersection of the line that passes through the point these 2 points form and the line perpendicular to that line that passes through the point 0, minus 2? Now we want to know the point of intersection of the line, which means the point where x and y meet. Now how can we solve this? Follow me. We are given the point which is 1, 5, and we have another point 3, 9. So this one is x1, this point is y1, this point is s2, this point is y2. Now don't forget the equation of the line, which is y is equal to mx plus c. This is the general form of equation of a line. Now we have the equation in form of y minus y1 equal to m into x minus x1. Now it passes through this point, which is in this 1 point form. That's why we have this formula like this. Now we need to determine the gradient, which is our m. And gradient will be equal to what? y2 minus y1 over s2 minus x1. Now what's our y2? That will be what? That will be 9 minus 5 over 3 minus 1. So our gradient will be equal to, this one will be 9 minus 5, that's 4. 4 divided by 3 minus 1, that's 2. 4 divided by 2, we have it as 2. So our gradient here is 2. Now let's come back to the equation. So let's substitute y minus y1, which is 5, equal to m, which is 2 into x minus x1, which is 1. So now let's expand. Y minus 5 will now be equal to this one, 2 times x, 2x, 2 times minus 1, that's minus 2. Now y will now be equal to 2x minus 2 plus 5. If this minus 5 comes here, it becomes plus. So y will now be equal to 2x plus 3. This is the first equation of the line. Now we need to determine another equation of the line, which is perpendicular to this line that passes through this 1 point form. Now how can we do that? We can have it as what? Since we need to know the condition for perpendicularity, so we need to determine our second gradient, which is m1 is equal to minus 1 over what? Over m2. And we have the first gradient as 2. So 2 will now be equal to minus 1 over what? Over m2. So automatically our m2 will be equal to what? Minus 1 over 2. Now let's come back to the equation, which is y minus y1 equal to m into x minus x1. Now at this point, we have the points, the second point here for the perpendicularity as 0, minus 2. So this one will be x1, this one will be y1. So now y minus y1, that's y minus minus 2, that's y plus 2 equal to the second gradient, which is minus 1 over 2 into x minus x1, which is 0. So now we can have this one as y plus 2 equal to x minus 0 is s times this, we have it as minus x over 2. Now at this point, we can have it as y will now be equal to minus x over 2. Let's move this plus 2 here, it becomes minus 2 also. Now we have the second equation of the line. Since the points they are what? They are intersection. There is an intersection point. That means we need to what? We need to equate this first line equation of the line and this second equation of the line, because we are looking for the point of intersection. So that means we need to equate the two. So therefore 2x plus 3 will be equal to minus x over 2 minus 2. Now we can have this one as, let's clear the fraction and multiply 2 by the LCM. LCM here is 2. So if we multiply all this one by 2, we have it as 4x plus 2 times 3, that's 6, equal to this one will be minus x minus 4. So now we have 4x. If this minus x comes here, it becomes plus x equal to minus 4 minus 6. So 5x will now be equal to minus 10. So the value of x here will be equal to minus 2. Now as the point, don't forget we are looking for the point. So the first point is minus 2. Now what of the point y, which is x comma y? Now substitute this value of x into this point, this first point equation of the line. So we have it as y will now be equal to 2 into minus 2 plus 3. So y will now be equal to 2 times minus 2, that's minus 4 plus 3. So y will now be equal to what? Minus 1. So the second point of intersection is what? Minus 1, which is s comma y. So this is the final answer for this particular question. Please don't forget to follow, share and like so that others can benefit. Thanks.